Hey, welcome back, class. This is week five's video. You guys did fantastic on your topic 2 assessment from last week. If you haven't done it yet, please make sure you go back, get caught up, take your topic 2 assessment, because today in this lesson we're starting unit 3 or topic 3, which is algebra. I've been looking forward to this all year. You guys are going to do fantastic with this unit as well. Today we're going to start with exponents though. Not too hard of a concept, and some of you have probably already seen it before. So for this week, you're going to see a few things inside your folder. The only graded assignment is the 3-1 practice problems, but I wanted to give you extra work in there. It's not for a grade, but it's something to be able to practice with and to practice the skills we're going over this week. So you'll see something called extra exponent practice and doodle notes exponents. That will also be inside the folder. Again, it's not for a grade, but it's something to help you practice what we're going to learn today. It's what we would be working on in class itself. All right, I made it so that you could either download the PDFs or you could use Kami in order to send the submission in. So if you would like to practice those and you would like to turn them in, feel free. There's a few different ways that you can submit the work. But the only assignment that is for a grade is the 3-1 practice problems, and that's just like every other practice problem we have done so far this year. It's all in Schoology. The third thing I want all of you to make sure you're doing is get caught up. This is the last full week before we leave for winter break. Like I said in the last couple of videos, this 9 weeks is going to fly by because of these holiday breaks. So just make sure before you leave for this winter break and for all of the holidays, just make sure you're caught up, okay? Because it would not be good for you or for me for grading wise for you to have like 6 missing assignments. Get everything turned in, get caught up before the holidays. That way when we get back from the holidays, you can start fresh. All right, so there's the 3 things that are inside your weekly folder. So let's hop into today's lesson. So I talked about this in the last video, but I'll say it again. We are having live classes. Make sure you're checking with your other teachers to see when their live classes are, because they're being held all throughout the week at different times. So for my live classes, they're not mandatory. You don't have to join. I would love to see all of you in there because I'm going to be reviewing this material more in depth, and it gives you an opportunity to ask me questions. And on the other days that we have live classes, I've been recently doing quizzes, Kahoots, some fun things to give us some review. All right, so it's a good way to practice, ask questions, and engage as if we were in class. So my live class times will be Monday, 9 a.m. to 10 a.m., and Thursday, 12 p.m. to 1 p.m. I still have my office hours from 9 a.m. to 2 p.m., so feel free to stop by at any time on that day as well. Now, all of these sessions are held in Mr. Dotson's Math Crew. You go to the Groups tab at the top of Schoology. You click on where it says Mr. Dotson's Math Crew. It's a blue icon. And then you go to the Conferences button on the bottom left. Once you click there, you'll see the conference at these times that you can join. Okay, so I hope to see all of you there. Throughout the school year, I like to play these corny videos for you. So to start off this unit, I figured let me find you another corny video. And it is talking about what we're going to learn today, which are exponents or powers, as you see. So sit back, make sure your volume is turned up, and let's watch this corny video together, and we'll go more into depth after.
Is what you get when you multiply a number by itself one or more times. To give you one example, let's look at powers of the number 5. 5 times 5 is 25. 5 times 5 times 5 is 125. 5 times 5 times 5 times 5 is 625. There's 2 parts of a power: a base and an exponent. The base is on the bottom, it's the number being multiplied. The exponents on the top, it tells you how many times the base is multiplied by. Where's the base? The base is on the bottom. Where's the exponent? The exponent's on the top. 5 times 5 is 25. 5 times 5 times 5 is 125. 5 times 5 times 5 times 5 is 625. Now let's look at the 3 different forms of exponents. You might find that you already know them. 2 to the 3 is known as the exponent form. It's because there's an exponent in there. 2 times 2 times 2 is the expanded form. It's because you've expanded the exponent form. And the result of 8 is the standard form. A plain number is the standard.
So that's the corny video, but hopefully what you got from it is that all we're doing here is we're looking at numbers that are multiplied by itself many different times, because that's how we write and that is what an exponent is. So let's look at this first example and see if we can apply what the video was talking about. So it says the expression 2 times 2 times 2 represents the number of cells after 1 hour if there is 1 cell at the start. How can you write this expression using exponents? And then it says how many cells will there be after 1 hour. So what the video was saying is that when we have repeated multiplication of the same number, we can use the exponent in order to describe it. So we have 2 times 2 times 2. So when we want to write that in its exponent form, we just say that the base, which is the bottom number, what number do you see multiple times here? 2. So my base is 2. And then our exponent tells us how many times our base is written. Well, how many 2's do you see here? 1, 2, 3. So 2 times 2 times 2 means 2 to the power of 3. So 2 to the power of 3 is just 2 times 2 times 2. It's 2 multiplied by itself 3 times. And you may have heard this before, another way that you could say 2 to the power of 3 is 2 cubed. That's another way that you could say it. So the exponent form has a base, the bottom number. So base is this bottom number. It's the big number. And this little number over here is called the exponent. Exponent. The little number tells you how many times to multiply the base by itself. Exponent. So the question said, how can you write this expression using exponents? Here we go. That's it. 2 to the third power. Then it says, how many cells will there be after 1 hour? So that's 2 to the third power, which we just said is 2 times 2 times 2. So this is the exponent form. This is the expanded form, 2 times 2 times 2. And then the standard form is when we solve it. So what's 2 times 2? 4. What's 4 times 2? 8. So the standard form, or the answer to this problem, would be 8, or 8 cells. And that answers the question. So that's why we write it as an exponent form. Instead of saying 2 times 2 times 2, which kind of takes a little bit of time, we can just say it's 2 cubed, 2 to the third power. And the way that we solve that is we just multiply 2 by itself 3 times. 2 times 2 is 4. 4 times 2 is 8. And that's it. So the reason that this is important, though, to relate it to nowadays and what's going on with COVID, so one thing to think about is that if a cell can replicate itself very fast, it rises exponentially, right? So in 1 hour, when we start, let's say if we started with just one cell in 1 hour, now there's 8 cells. Well, how many would there be after 2 hours? So if we doubled this, 2 to the third power, well, what if it were after 2 hours, 2 to the sixth power? So let's think about that. 2 to the third, so 2 to the third power is 2 times 2 times 2. Now what we want to do is multiply 2 to the sixth power, which is 2 times 2 times 2 times 2 times 2. So that's 1, 2, 3, 4, 5 times 2, which is 2 times 2, 6 times. Well, what would that be? So we would need to take it one step at a time. Well, 2 times 2 we already said is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that means after 2 hours, there would be 64 cells. So you can see how exponents saved us a lot of time. So instead of saying 2 times 2 times 2 times 2 times 2 times 2, I could have just shortened that and said 2 to the sixth power and solved it to get 64. And a little fun fact for you, all of your phones, if you have a phone or a calculator, the shortcut in order to solve 2 to the sixth power, if you look very close on a calculator, you'll see this little up icon, right? It kind of looks like a caret is what they call it. That means 2 caret, so to the power of whatever it might be. And if you look at if you're on a computer, if you look at the number 6 on your keyboard, you'll see that caret icon. That means to the power of. So 6 caret 2 means 6 to the power of 2. So if you wanted to solve this problem on a calculator, you would type in 2 caret 6 and you would get 64. Okay, so that's how we can use exponents. Let's try some more examples. So exponents can be just regular numbers, but we can also use fractions, we can also use decimals, and sometimes your exponent won't be just a regular number, it'll be 0. Right? So let's look at how those types of numbers affect one another when we're looking at exponents. So letter A here says, how can you evaluate 2 to the power of 0? So before we actually answer that, let's look at 2 to different powers and see what it really is telling us. So 2 to the power of 0, we'll come back to that like I said. But let's solve some other ones. 2 to the power of 1, technically what that is telling us is that it's 2 written how many times? Well, it's 2 multiplied by itself just once, right? So 2 multiplied by itself once is really 1 times 2, because 2 is written one time, which is what? 2. So 2 to the first power is 2. 2 squared, so 2 to the second power is 2 times 2. And I'm just say times 1 because anything times 1 doesn't change itself. 2 times 2 is 4. So 2 squared, or 2 to the second power, is 4. How about 2 to the third power? Well, that's 2 times 2 times 2, and again, I'm just going to put a 1 in front. 2 times 2 is 4. 4 times 2 is 8. And 8 times 1 is 1. So, sorry, 8 times 1 is 8. So 2 to the third power, or 2 cubed, is 8. So knowing all of this, what would 2 to the power of 0 be? Now think about it, right? What's happening from 2 to 4? What's happening from this 2 to this 4? Let me change colors so it's not all red. How do I get 2 to 4 and 4 to 8? What's happening? What are we seeing is happening here? You're multiplying by 2, right? 2 to get to 4 is you times it by 2. 4 to get to 8 is timesing it by 2. So 2 to the power of 0, well, 2 to the power of 0 would be what? Well, really, if I stick to what we are saying here, 2 to the first power is just 2. So 1 times, if there's, the exponents tell me how many 2's there are, well, the exponents tell me there's no 2's, right? So I leave it at just that. It's just 1. There are no 2's here. I don't write anything here. So 2 to the power of 0 is 1. And if I look at my pattern here, isn't 1 times 2, 2? Yeah. So my pattern is able to continue. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So that is what any power of 0, any number to the power of 0 is just 1. Okay, so if I said 543 to the power of 0, what would that be? 1. Any number, it could be 1/3, right? The fraction 1/3 to the power of 0, it'll still be 1. Any number raised to the power of 0 will be 1. Remember that. That's the 0 power rule. Now let's look over here. It says, how can you evaluate 1.2, right? So 1 and 2/10 raised to the power of 4. Well, this exponent isn't attached to just the 2. It's saying 1.2 times itself 4 times. So if I were to write this in expanded form, 1.2 times 1.2 times 1.2 times 1.2. So now I've taken my 1.2 and I'm expanding it. So I went from exponent form to expanded form. It's 1.2 times 1.2 times 1.2 times 1.2. I wrote it 4 times. Now I just need to solve it. So I would have to do 1.2 times 1.2 times 1.2 times 1.2. For this lesson, I'm okay if you use a calculator. You know how to multiply decimals, hopefully by now. A calculator can be used. Even on your practice problems on Schoology, I enabled it so you could have a calculator. So don't be alarmed. I'm going to cheat. I'm going to use my own calculator too. So let's do 1.2 times 1.2 first. That gives me 1.44. So now I need to multiply that by 1.2. And then whatever I get, multiply that by 1.2. Right? Because I did these, I have these left. So 1.44 times 1.2 is 1.728. And then I need to multiply that by 1.2. So equals times 1.2 is 2.0736. So 1 and 2/10 raised to the power of 4 is 2.0736. Okay? And another way that I could have done that, if I were to show you on my phone, So if I typed in 1.2, for a lot of you, I have a Google phone, if you swipe over, you'll see that caret icon right there. If you type it, now it says 1.2 caret. That means 1.2 raised to what number? Well, my exponent is 4. So if I did that, 1.2 raised to the power of 4, I get 2.0736. And there's your answer. Okay, let's try one more. Okay, so in the other example is what we were doing is we were evaluating powers. But you can also evaluate, which means to solve, an expression, which is just a question that's being asked of you. It's just a math problem, right? So it says Julia calculated the FOIL as 1.9, so 1 and 9/10 times 10 to the 5th power units thick. Okay. Thom calculated the FOIL as 183,000 units thick. Which calculation represents greater thickness for the foil? Okay, well, we can understand 183,000 units thick. That we can understand, right? 1.9 times 10 to the 5th power, I can't really visualize that. So we want to evaluate that expression to compare the two numbers. Okay? So the way we do that, if we have 1.9 times 10 to the 5th, you want to solve that exponent first. So we want to solve what's 10 to the 5th power first. So 10 to the 5th power, let's just ease up to it. Well, what's 10 to the 1st power? 10 to the power of 1 is just 10 multiplied by itself one time, which 10 to the 1st power is 10. Okay, so far so good. 10 to the 2nd power, so I'll say 10 to the 1st is just 10. 10 to the 2nd power written in expanded form, is 10 times 10. Well, what's 10 times 10? 100. Okay. So far so good. We're getting there. 10 to the 3rd power. 10 to the 3rd power in expanded form is 10 times 10 times 10, which is 10 times 10 we said is 100. 100 times 10 is 1,000. Okay, so we have 1,000. Are you noticing a pattern here? Hopefully. 10 to the 2nd power, we wrote 1 and how many zeros? 2. So 10 to the 2nd power is 1 with 2 zeros after it. 10 to the 3rd power, we write 1 and how many zeros after it? If it's 10 to the 3rd power, 1, 2, 3. So 10 to the 4th power, I'm just going to write over here, 10 to the 4th power would be 1 with 4 zeros after it. 1, 2, 3, 4, which would be 10,000. So what does that mean 10 to the 5th power would be? It would be 1 with how many zeros after? 5. 1, 2, 3, 4, 5. So 100,000. So we just solved what 10 to the 5th power is. It's 100,000. So let's solve the entire expression. 1.9, so 1 and 9/10 times 100,000. If we were to estimate, right, if we were to just guess what this would be without a calculator or anything like that, 1.9 is really close to 2. So 2 times 100,000 would be 200,000. So 1.9 would be 190,000. So our answers are very close. So 2 times 100,000 would be 200,000. 1.9 times 100,000 is 190,000. So it says, which calculation represents the greater thickness? So Julia said that it's 190,000, and Thom said that it was 183,000. Well, what's greater? Julia's. So this would be greater. All right, let's review a little bit and look at some questions that are similar to the practice problems on Schoology, and we'll see how we do. So the types of questions you're going to see on Schoology are going to look like this. The first one says, what is 3/8 times 3/8 times 3/8 written as a power? So be careful on this because we have a fraction and we want to figure out, well, what would this be written as a power, right? 3/8 times 3/8 times 3/8. The first thing you want to figure out is what is our base? So what should our bottom number be here? 3/8, right? Because I have 1, 2, 3, 3/8. That's the number that's being repeated. So my base, although a fraction, is 3/8. Now, to figure out what the power is, my exponent, how many 3/8 do we see? 3 of them. So my exponent is going to be 3 because that's how many times 3/8 is written. Now, be careful. This is what I mean when it comes to fractions and we're trying to write it as a power. Right now, it looks like we're good. But technically, this exponent is being attached to this 3, when in reality, we want this exponent to be attached to the entire fraction. So the way that we need to really write this is put parentheses around the fraction to show that 3/8 is its own unit, and we're raising that to a power of 3. That way it's 3/8 times 3/8 times 3/8, not just 3 cubed divided by 8. Okay? So be careful when it comes to fractions. So that would be our answer for the first one, and we don't need to solve. We can if we want, but you don't need to. It's just asking what is it written as a power. Now this one says evaluate the power 1/6 squared. So 1/6 to the power of 2. Well, what's this in expanded form? 1/6 is my base. My exponent is 2. So this is really telling me it's 1/6 multiplied by itself twice. So I have 2 1/6ths here. Okay, not too bad. But it says evaluate the power, which means I need to solve it. So this is the expanded form, but I want to write it in standard form, which means to solve. And how do we multiply fractions? See, this is why we learned that in the beginning of the year. We multiply fractions by multiplying straight across. 1 times 1 is 1. 6 times 6 is 36. Can that be simplified? Nope, because our numerator is 1, so it can't get any smaller. So my answer is just 1/36. Done. The last one. Evaluate the expression 3.4, so 3 and 4/10, times 10 to the power of 0. So let's think about this. Just like the last example we talked about, the first thing you want to do is evaluate any exponents we see. Do we have exponents in this expression? So let's solve this 10 to the power of 0 first. Remember back to the second example we talked about. Anything to the power of 0 is 1. Always. That's the power of 0 rule. Anything to the power of 0 is 1. So 10 to the power of 0 is just 1. So this transforms to, let me choose another color, 3.4 times, and what did we say 10 to the power of 0 was? 1. Well, 3.4 times 1 is what? 3.4. And that's it. That's all you have to do. And you're done. So hopefully that made sense. These are the type of problems that you'll see on the practice problems on Schoology. So make sure if you're confused when you're working on it, come back to this slide, see how we did these problems, and hopefully it helps. Okay? So that's all I have for you for this week. Again, please remember, if you have any questions, I hope I see you all on Monday and Thursday during my live classes. Monday is 9 to 10, and on Monday we're probably going to be just reviewing what this video went over to give everybody some more practice, to explain some things. So if you have questions, join on Monday. And then on Thursday, what I'm planning on doing is reviewing everything and playing a game of Kahoot. So if you'd like to play a review game, please join us. It'll be a good time. I think we had like 10 people last Thursday. We played a quizzes, and I gave bonus points on the test if you joined. So there's incentives for you to be joining our classes. They're not mandatory, but I do hope to see you all there. All as always on Wednesday from 9 to 2 p.m. I have office hours, so feel free to stop by at any time. We can work on some problems. We can work on the practice problems or any of the other assignments that I gave you for this week. So thank you all for watching the video. I hope to see you all throughout the week. And if you have any questions, send me a message on Schoology as always. And I hope to hear from everybody. You guys are doing great. Keep up the good work. If I don't hear from you, see you in the next week's video. But as always, stay safe, stay healthy, and I will see each and every one of you in the next video.